All right, so this is module 3 of this course, and I'd like to introduce to you GeoGebra, which is a lovely dynamic geometry package that your students can download for free, and that's quite well used in high schools around the world. It gives us a lot of flexibility to visualize geometrical things, especially constructions, and allows us to move things around and see how the various parts of a construction will move if we change the inputs. It's also a great tool for calculus because we can graph functions very easily and tangents to functions and so on. So it's also a powerful aid in illustrating calculus ideas to students. So let's have a look at how this works. All right, so I want to give you an introduction to GeoGebra. We'll start by just having an overview of the program itself and some of the basic tools and operations. And then we'll go about trying to create a Bezier curve or two. All right, so here's our basic screen. And let's have a look at what we're seeing. We have some various tools as usual. And here we have two views, an algebra view and a graphics view. The graphics view is where most things happen. So under File, well, we can open a new window. We can open windows that we've already created. We can save. We can export. Under Edit, we have the important Undo button, which is a Control-Z, or we can redo the Control-Y. With View, we can see the various possible views. So we see that there's an algebra view that's on the left panel. We have our graphics view in the middle here. Sometimes it's interesting to have a spreadsheet view as well. We're not going to use that. But I do point out that we have this input bar, which is down here at the bottom, which is a very important way of also constructing things. We have various options for changing font sizes and rounding and so on. And then there's a section for creating tools, which is a bit more of an advanced feature that we won't talk about. And here's our window, and we have some help. All right, let's go about now actually creating something, and we'll see how these various construction tools that have already been created can be used. All right, let's start with a point. All right, so I'm going to click on here. Actually, you see there's a drop-down window here. If we look at this little button here, there's various things that we can do in terms of creating points. We can just create a simple point, which I'm going to do, but we could also create points by putting them on objects that already exist, or we can attach and detach points from objects. We can also intersect curves, which is a very useful thing to be able to do. But for us, let's just create a point or two. So here's a point. Just click on anywhere. Here's another point, and here's a third point. So we've created 3 points, and they're called A, B, and C. And over in the algebra view, you can see the coordinates of the 3 points with respect to our coordinate system here, which you can see. Now, if I go back to the Select button, then I can click on any point, and I can move it around, and you can see that the coordinates of that point change as well. Let's create some lines. Here there's also a drop-down button. So maybe we'll create intervals or line segments between points. So I click on that button. I see the line interval tool there. And now I can click on A and B, and I get the line segment joining them. And click on B and C, and I get the line segment joining them. You'll also see that GeoGebra has automatically measured the lengths of these line segments and recorded those lengths there. We don't really need those. In fact, I could get rid of them. All right, so one other thing we might like to do is a polygon. So here we can create a polygon, let's say a triangle, starting with A, and then B, and then C, and then going back to A, finishes the polygon, and there it is there, it's a triangle. So there's a few other things that we can do. We can, for example, create a circle. And there's various options for creating circles, say starting with a center through a point, or a center with a given radius, or a circle through 3 points. We can create conic sections, for example, an ellipse. If we click on 2 points and then a third point, then we get an ellipse whose foci are the first 2 points which go through the third point. Another nice construction is the conic through 5 points button, which allows us, if we click on any 5 points, gives us the unique conic which passes through those points. And then if we drag any of the points around, well, then we can get different kinds of conics, sometimes ellipses, sometimes hyperbolas, and occasionally maybe something like this is a parabola. All right, now I'm going to just get rid of those by, say, Control Z. Control Z gets rid of that. If I want to get rid of this conic, another way of doing it is to click on the conic and maybe right-click and delete. These points here, D, Shift down to F to select all of them, right-click, delete gets rid of them. And we're back to our triangle ABC. All right, I want to now create a Bezier curve, and for this I'm going to introduce this very important idea of a slider. This is a way of introducing a parameter into GeoGebra, a very useful thing. So we're going to click on here and take the slider button, and over here I'm going to click somewhere, and we get this text box. I'm going to rename the slider T, and in terms of an interval, I'm going to go from 0 to 1. Be like a parameterizing a line segment. So here now is our slider bar going from 0 to 1. And I see it's a little bit coarse. So if I click on Object Properties, then under here, under Increment, I might change this 0.1 to a 0.01 and close it. Now you can see that the parameter varies more smoothly. All right, so what can we do now? Well, I want to create a Bezier curve, a quadratic Bezier curve with these as the control points. So to fit with our earlier discussion, I want to relabel these points. So let me call this first point P0 instead of A, and the second point P1 instead of B, and maybe the third point over here, rename it P2. All right, so there's P0, P1, and P2. And now we're going to create some more objects, but we're going to use the input bar to do that. This is a very important alternative way of introducing objects. For example, if we wanted to introduce an ellipse via an equation, so x squared plus, say, 3y squared equals 4, I write down that equation and press enter, well, and I get an ellipse with that as the equation right there, x squared plus y squared equals 4. Okay, I actually don't want that one, so I'm going to delete that. But we're going to input some points on these line segments, which are determined by this parameter t going from 0 to 1. All right, so our first point is Q0. And I'm going to define that in terms of the slider. So I'm going to use this value t. I'm going to create 1 minus t, then times the point P0. And I'm going to use this star button for times. And then plus t times P1. This is giving us a convex combination of P0 and P1. Let's see what happens if I press enter. You see I get this point Q0, which is right here. And it depends on the slider's value. So as t goes from 0 to 1, this point Q0 moves from P0 to P1. Similarly, let's create Q1, which is equal to 1 minus t times P1 plus t times P2. There it is there. Now I'm going to take both of these, Q0 and Q1, and I'm going to select both of them, and then I'm going to right-click, and let's make them a little bit bigger. 5. While we're at it, let's make it a little bit more colorful. Let's say green. All right, so there they are there. And as t goes from 0 to 1, you can see that they're both sliding across their respective intervals. All right, so we've made Q0 and Q1. Now let's make that third point, R0, that's going from Q0 to Q1. We'll do that in exactly the same way. Down here in the input bar, we'll write R0 equals 1 minus t times q0 plus t times q1. Enter, and we get r0 on this segment. Let's actually create the segment so we can actually see where it is. There it is there. All right, now as t varies from 0 to 1, you can see that this point r0 is moving along this interval that's itself moving, the q0, q1 interval. Let's take this point, make it a little bit bigger, and let's give it a bit more color, say blue. There it is there, r0. All right, so now we're in a position to get this Bezier curve, because all we have to do now is find the path that r0 traces as t moves. For that, we're going to use this Locus button. So down here under the drop down, there's this Locus button. If we click on that, then there it is there. And we click on Locus. We're going to now click on first slider and then the r0 button. And you can see this is now the locus, or the path, that r0 takes as t moves along its range. Let's make it a little bit more visible. Maybe make it red, and we'll make it a little bit bigger. All right, so there's our quadratic Bezier curve in red there. Control points P0, P1, and P2. And you can see the de Castelnau construction of this Bezier curve, depending on the parameter t, in a very simple but elegant fashion. And if we change our control points, well, then we can change the Bezier curve. And if we perhaps wanted to extend the Bezier curve, well, we could do that by having a look at the slider's values. The slider going from 0 to 1, if we make that, say, from -1 to 2, then what's happened is that we've extended the range of the Bezier curve to extend beyond the control points. All right, now let's have a look at going to 4 control points to create a cubic Bezier curve. So we're going to modify this a little bit. We can get rid of a few things. We don't need that quadratic curve anymore. We don't really need the triangle anymore. But we do need another point. So there's another point, and we'll call it P3. And we need a new segment from P2 to P3. And then on that segment, we need another point like Q1. So we'll say that Q2 equals 1 minus t times P2 plus t times P3. Right, and that gives us this corresponding point Q2 here. Now let's join up Q1 and Q2. And on this segment, we're going to create a new point that's just like R0. Namely, R1 equals 1 minus t times Q1 plus t times Q2. Great. All right, now let's take these 2 points, R1 and R2, and select them both and make them a little bit bigger. Good. And this one here, we're going to color the same color as our point R1. Now we're going to connect R0 with R1. And on this segment, we are now going to create the point S0, which is 1 minus t times R0 plus t times R1. All right, there's S0. All right, now watch what happens as t varies. As t varies, Q0 goes from P0 to P1, while Q1 goes along this segment, Q2 goes along this segment. And at the same time, R0 is moving along this interval, and R1 is moving along this interval. And S0, which ought to be bigger, and we said pink, is going to be moving between R0 and R1. All right. And now, to get the actual cubic curve, we're going to take a locus. As t varies, we're going to look at the locus of S0. And when we click, we see we get this cubic de Castelnau-Bezier curve. And to be consistent, let's color it red along with the previous one. And maybe we'll make it a little bit thicker so you can see it better. There it is there. And now let's see how this cubic Bezier curve depends on the 4 control points. All right, so we can move them around. We have quite a lot of flexibility in how we do that. We can go like this as well. You can see that we get some nice shapes. It's always a cubic curve, which has the property that these lines from P0 to P1 and from P3 to P2 are tangents to the curve at P0 and at P3. All right. And so again, once we'll run through T, going from 0 all the way up to T1. If we want to do that automatically, we can right-click and put animation on, and it'll be going back and forth automatically. We can see very nicely how the de Castelnau algorithm traces out our cubic curve. So I hope you enjoyed that introduction to GeoGebra and how we created these Bezier curves, a quadratic one and a cubic one. And now it's a good exercise for you to see if you can first of all replicate these constructions. You can show your students how this goes. And you can also try to do the analogous thing going up 1 dimension to going to a quartic de Castelnau-Bezier curve by introducing a 5th control point. That might be fun exercise to try.